And good afternoon, everyone. Thanks for jumping on. Another ATS University, this one on automatic control valves and some corrosion protection products that are being added to these valves to extend the life expectancy. This is part of a continued update on a number of, we'll call them kind of old and tested products from Watts. They've got a variety of, they've been known in the ACV and the backflow world for a long time as a leader, and this is part of their continuing development of the product line to ensure great life expectancy with all their products. My name is Zach with ATS. I am the market development manager across North America for our outside team, although the outside team is also available for all sorts of online presentations or one-on-one demos of our ATS spec systems if you ever need help getting a project put together or need help navigating the site, maybe getting your masters set up. At the end of the presentation, we'll do a quick run through of what I'm talking about. That if this is your first time on an ATS University, we'll show you how you can find all the products that we're discussing today. But really, without much further ado, well, one piece, I always forget this, but as with all of our sessions, this is going to be recorded. So I'll be keeping an eye on the chat field, and we have everyone muted upon entry, just to make sure that no one's jumping in. But if you have any questions along the way, please feel free to pop them into the Q&A or the chat fields. And as with all of our ATS University sessions, we'll be sending out a certificate of attendance at the end of the week. And if you end up not receiving it, please just shoot at me an email. My information is there in my name, zach@atspec.com. We'll make sure that your certificate of attendance is sent out for any hours that you need to report. So without all of that further ado, we'll introduce Drew. Drew, you're a BDM for the ACV lineup, I believe up in the Northeast, right?
Correct. I'd like to first thank everyone attending the presentation on automatic control valves with our advanced corrosion protection called ArmorTech. It's a proven, field-tested coating that we developed many years ago, and it's been out in the field. So it's not just something that we're coating today, it's something that's been tested. We have an exciting launch coming up on it, but we've already have introduced it, as Zach said, on backflows and on automatic control valves. So I do automatic control valves. So today we're going to examine, Watts ArmorTech coating system and how it benefits automatic control valves. Part of this is we're going to describe some, you could say, ArmorTech ACV applications, so you could get an understanding of how this benefits the marketplace and actually opens up. And then, at the end, I know Zach has, a bunch of, additional, I'm going to say, not questions, but you could say part of the presentation. But what we're going to try to hopefully get across is how, and we could discuss with some questions, how this could benefit you. So with that said, the big as we do here is go over today's objectives. So when we finish, you should have a better understanding of ArmorTech. We're going to present and provide some cost-effective solutions to address aggressive water. And we're going to get into aggressive water a little bit. Effective control for microbial-induced corrosion, which is MIC. The benefits of using ArmorTech on ductile iron, you could say valves, backflows, and ACVs on aggressive water. And we're going to go over aggressive water because everybody's running into it more and more, especially as wells get deeper, limestone applications, you could say reuse water. We'll go over some field applications and installations and some ACV, again, products using different applications. So with that said, what we've done is, take a look, and this map is basically from the United States Geological Survey, and it's based on where I'm going to say domestically, where aggressive water is starting to be seen and affecting. And when we talk aggressive water, it's soft and acidic. Um, it will dissolve metal materials when it comes in contact with, such as copper, lead. You see that sometimes you get pinholes in copper tubing. This is a naturally occurring water condition. It can become problematic when it dissolves these metals, especially in municipal and city water distribution systems, because those valves are in remote locations or they're controlling water, pressure flow in remote locations. The United States Geological Survey works with many partners to provide, objective and impartial science um, to these resources, especially throughout the United States. In emergency response, it gives the public, you could say, why their water is maybe corroding around their expensive fixtures. So it's not only just for the government, but also for the homeowner. Water, basically, with a pH, aggressive water, excuse me, with a pH below 6.5 will dissolve, and it's very corrosive because of its alkalinity is very low. And water values with a pH above 7.5 also can be corrosive when its alkalinity is low. And again, what is alkalinity? It's important to understand this because this is really what is really measured to resist, you could say, the acid in the water or acidification. It shouldn't be confused with any, I'm going to say, being basic. It's an app, and it's not part of an absolute measurement scale of pH. The minerals, when you dissolve copper, lead in the system, you could say, these minerals, are dissolved in the water and they separate into charged particles. And that's important because that could also conduct electricity based on the chemistry. One of the other areas in this is carbon dioxide. And again, carbon dioxide is very important to understand because with a high pH, the CO2 content water will tend to deposit, you could say, calcium carbonate, as you see, like the crust or the formation, and is designated as a scale forming. When the pH is low, or the CO2 level will tend to dissolve the calcium carbonate and is then, turned aggressive. Again, where's calcium carbonate coming from? The limestone plates, fertilizers, a lot of chemicals, even, quote, acid rain. So water, again, is problematic and becoming more because there's more CO2 in the air. There's more, the calcium carbonate. We're drilling deeper into the limestone, especially in the aquifers. So what's happening is the pH is actually getting out of the neutral range. So we term as aggressive water is that the valves are going to have to be, I'm going to say, taking a simple ductile iron technology, and we've got to improve it and actually improve it into today's, you could say, technology. And it's important to understand that.
So one of the quick questions coming in there is whether or not there's a corrosion map for Canada. I don't think we have as part of the presentation. I know it's relatively similar to the map that we have for the US. Like it really kind of follows similar lines. But what we can do is try to see if we can get a copy of that map, and for
Sure.
having all the other Canadian engineers as part of our follow-up, we'll try to send out a copy of the Canadian version of the map.
Absolutely. We could take a look at that, and I apologize because I know there's fair amount of people from Canada on this.
It's a diverse audience today. You got people from down south, you got people out west, out
Yeah,
east.
you got everywhere. But it's the same thing. What's happening everywhere is when there are even I'm going to say wildfires, and you sit there and say, what does that mean? Well, everybody sees the smog in the air and then the rain and it clears up. Well, where's all that? I'm going to say dust, pollution that goes into the reservoirs. That's actually part of polluting and making that water aggressive. So there's a lot, going on today. And now, again, when it seeps down into the aquifers, you start getting deeper. You start seeing aggressive water. So what's happening is people are starting to move away, especially in valving, is to have copper or, lead components like tubing, or it could be fittings, and to go to more stainless and lead-free fittings also, on there because of corrosion. So we're going to talk a little bit about also Mick. And again, corrosion can form in fire service and reclaim systems. And I have that up top because it's important. Mick could be anywhere, but a lot of fire water, or you could say fire service systems, because of the stagnant water, has Mick in it. And we'll go a little more into reclaim system or reuse or systems. But again, Mick is micrologically influenced corrosion. And it is the presence of and activities of microorganisms. Mick always occurs with other forms of corrosion. So high oxygen, crevice, it sits in there because of the bacteria building. And a common bacteria associated with Mick are sulfate reducing bacteria, or acid producing bacteria, or it could be iron reducing bacteria. And there are these forms of bacteria out there. The most common form of the corrosion influenced by Mick are the, pitting corrosion, crevice corrosion, and stress cracking corrosion. So, when you see Mick, you'll see a butterfly valve, you could say the seal, or really the I call it the plate, almost eaten away. You'll see inside pipes heavy Mick, or you'll pull apart backflow and you'll see all this corrosion sitting in there. That's Mick. And the Mick has been identified as a major problem in numerous industries, from surface water, municipal reclaimed water, gray water, and even well water has Mick and is consumed when the conditions are right for formation of these microorganisms. They generate sticky biofilms, which then adhere to the, you could say, this host surface or the metal surface, and they create their own environment with the surrounding metal. And then these variations start dissolving water. They like a low pH, and especially when inorganic compounds with these little micro environments result in electrical potential differences. So again, we're going back to not only they grow, but when they start changing the electrical potential of the surrounding metal, it actually accelerates. So, you could see on this slide here, everybody, if you take apart some sprinkler heads, or some fire system, you get the black rotten egg smell or that black or red water coming down, and once it hits the floor and it gets on you, it stains. I mean, everybody has, a lot of people have run into, mick, not knowing why, that water's black or red or it smells, but that's actually mick in the pipes. And then on top of it, it starts creating leaks in the pipe wall. We're not going to talk about it today, but that's part of a pressure management, is because as mick keeps on eating its way and creating these pin leaks, when pressure becomes large or greater and you start getting pressure transients, you start getting main breaks, at that point. And again, the mick deposits, you could see, in the picture here, how, distinguishing between highly, active corrosion cells. And you could see the deep pitting in the surface. So again, what just kind of bringing out, you could say, the problem sitting out there. And, one of the other is corrosion problem. I call it out of sight and underground, because everybody runs into the same issue. You have vaults out there. You have, valves sitting underwater, and it could be from rain. It could be from just natural occurring coming up through the bottom. And really, this is really external corrosion, which is really dependent on the, atmospheric conditions and the installation. If you're near, it's humid, seacoast locations are more corrosive than dry inland locations. I mean, that's understandable. Chemical corrosion from nearby plants, can increase the corrosivity of the atmosphere. Locations where rainwater can accumulate on the valves are especially prone to external attack. Then obviously submersion in vaults filled with rainwater or groundwater, have a very low pH. So really, one of the big things here to understand is the susceptibility to external corrosion is also the temperature. Coating life can be degraded by environmental conditions, operating conditions, and mechanical damage. So there's a bunch of, you could say, external conditions that could also corrode valves sitting there. So where are automatic control valves located? Almost in a lot of different regions and markets, from plumbing and mechanical systems, high rises, municipal, irrigation, industrial water, reuse water, wastewater, shipyards, fire protection systems. They're a very inexpensive valve that controls pressure and flow, safely. One of the reasons why they're used is because they do have a precision and accuracy to provide that exact pressure flow, and down to level, surge, and pump control. And level being, they could control water towers so that you don't get overspillage based on head pressure. One of the things, they're very low maintenance valves that can handle extreme pressures. Engineers wanted to write specs to the contractors who need high performance valves at an affordable price. One of the things in Watts is that we have an ACV team that helps with the improved distribution understanding, efficiency. We could provide cost-effective solutions to minimize downtime. So we're going to get into a little bit of armor tech to help you. We've gone from some of the corrosion issues out there, where it sits, mick, underwater. But now, why did we at Watts sit there and say, we're going to have corrosion protection for ductile iron control valves and backflows? And we're going to go through now at this point. And our product's called ArmorTech, which is an advanced coating system. And it's on ductile iron valves for aggressive water applications. ArmorTech is a micro composite coating with really superior adhesion and abrasion resistance qualities. It reduces undercutting and aggressive water. It's excellent in a standalone performance in long-term atmospheric exposure. It's suited for industrial waste, industrial water, wastewater, shipyards, and freshwater environments. We finish the ArmorTech coating with an NSF ANSI 61 protective polyester top coat, not only to improve the aesthetics, but to increase long-term performance. And this is important because it's going into the potable water system. So we hit it with a three-prong approach out in the marketplace on ductile iron valves. So ArmorTech stops corrosion before it starts. What we're trying to do at Watts is to reduce capital and maintenance replacement costs on water systems using ductile iron valves. It's a field-proven three-prong approach. The protection is incorporating an anti-corrosion composite primer, and it was tested per ASTM. As you see, the degree of rusting, degree of blistering, and corrosion resistance. We've added a microbial inhibitor to limit or mitigate MIC. And then again, we finish it with a epoxy polyester primer for NSF 61. One of the keys, though, is we've also have tested it and field proven for salt spray. So we've done salt spray testing on this product for environmental corrosion. I talked a little bit before that we've been out in the field testing this. And one of the things out there is, I'm going to say a competitive product compared to our ArmorTech coating on our product. And what you see here are some backflows. And again, after 5 years, installing these valves, ArmorTech showed no signs of MIC activity and corrosion. The valve still looks brand new, as compared to other similar valves not treated with ArmorTech. Periodic maintenance is much more, I'm going to say, feasible because of the cleanliness of the ArmorTech coating. And what I mean by that is you want to make sure that simple maintenance, simple checks are done. You don't have to tear apart the valve. You don't have to tear apart and check for MIC, at that point. So it actually reduces the maintenance cost of the system. With the ArmorTech coating, on the valves, the customer now has a ductile iron valve protected against corrosion and could minimize the preventative maintenance. The coating is, designed to really, I'm going to say, protect the iron, ductile iron, and the microbial agent obviously, protects against the MIC. So we have that three-prong approach, as you could see here in the pictures, especially if it gets through the, I'm going to say pinhole or a pin, um, through the epoxy, which may have a, I'm going to say, on a coatings, they, you get these like sometimes little pin holes. It protects the metal below the epoxy surface. So, at that point, you get very, very high degree of protection with its coating. So, the top picture, again, you see the butterfly valve, and you could see the flapper there. It's eaten away, just corroded. So really, you know, corrosion coatings are used on reused or wastewater, recycled water for protection on metal surfaces. So corrosion coatings are a well-known technology out there. Uh, the low-level pH water, especially in reuse water, accelerates and promotes pitting, corrosion, and mick. In water and wastewater, the bacteria collects in pipes and treatment plants. Um, Again, protective coatings are a standard way and accepted on most metal surfaces as a cost-effective alternative to stainless. Um, you got to take into account external elements such as humidity, temperature, corrosive gases, especially when depending on the environment you are in on the external surfaces based on the location. So again, why do you need ACVs with ArmorTech? Again, micro, for mick, for being exposure to different soils. When something's buried in the ground, you say, well, it's in a vault. How many times have you walked up to a automatic control valve and seen it buried under dirt, or the soil there? So this, or it goes in a plastic vault, and again, soil is very acidic. You got seawater, distilled water, different chemicals. Again, many industries and water infrastructures are affected by mick, and we're going to get into that a little bit with water, including the water and wastewater. ArmorTech, versus stainless steel ACVs. Stainless steel and ArmorTech ductile iron valves. Corrosivity describes how aggressive the water is, to the corroding valves, pipes, and fixtures. When it comes to I'm going to say control valves, corrosion problems are something that, we've come to expect. One of the out there are both valves, ductile iron and stainless, are very strong, reliable. They, each have their specific, I'm going to say, advantage in the corrosive environments. However, there is a cost difference between an ArmorTech ductile iron stainless out there. What the idea here, why Watts has come out with ArmorTech, is to mitigate, expensive repairs, valve replacements, costly system downtime, and the compromise from water quality when the valve fails due to corrosion. Reduce, to reduce your corrosion headaches with ArmorTech and stainless steel valves are extremely important. We have, and now you could say a cost-effective corrosion coating on the ductile iron. But again, Watts, we also have 304 and 316 stainless steel. Stainless steel is an alloy, made with 10% chromium minimum, and it goes higher for corrosion. So when you look at the other elements in stainless steel, this isn't replacing stainless steel, but it does bridge the gap in do I need stainless steel for every aggressive water application? And one of the things to take a look at is a cost effective, I'm going to say ACV combination for aggressive water. Whereas we use Armor Tech for the main control valve, stainless steel tubing and fittings, stainless steel studs and nuts, and lead-free pilot controls. We're seeing more and more cities and municipalities going this route because of corrosion. They're looking for minimal downtime and easy PM. But one of the things to consider is the demands of the environment. And that will kind of tell you that you have to go with, and let's say, an Armor Tech ductile iron valve or a full stainless steel valve.
Well, and I think that's one of the questions that I'm having. And correct me if I'm wrong here. It sounds like the Armor Tech ductile iron really is kind of the middle ground in terms of your cost. It's a little bit lower than, say, the full stainless steel setup, which certainly is available for the higher end, the most aggressive,
Right.
especially going full 316. But it's not just your upfront cost; it's the life expectancy cost as well. It's being able to maintain rather than replace. Is that correct?
Correct. That's a good summation. The whole idea is to get the life out of the ductile iron valve, especially in aggressive water applications. That is really the one of the things why we did this, because as everybody knows, stainless steel material costs are always rising, and a lot of applications, even in municipalities, can't afford a full stainless steel automatic control valve or even backflow. So one of the ways we improve the situation is to provide Armor Tech, which again, we're going to go into some of the applications to help you bridge this gap of where, where it could be used in more aggressive areas. But by no means are we sitting there saying it's a stainless steel replacement,
Yeah,
because
well, and you can also consider, if you're familiar, if any of the engineers on the call are familiar with maybe doing full stainless steel piping projects, it's not just the fact that the costs are going up, is that it's hard to plan for the costs as they are so variable. Uh,
correct.
there's not a lot of standardization. If you're short on stainless supply, like a couple of years ago, prices and delivery times shot through the roof, and that's where this can be a cost-effective uh, opportunity, as well as like an easier planning, that's much more price steadfast.
Absolutely. We do water towers now with Armor Tech valves and stainless steel piping. Uh, Again, the piping um, is getting better, but Armor Tech isn't on, I'm going to say on, you could say steel piping out there. Steel piping has its own corrosion coatings, inhibitors. We focused on a product that it works in conjunction with stainless steel piping, where MIC has a high degree of happening, um, especially when you get into industrial water applications, or you even get into, again, low pH areas where the water's aggressive in municipalities, wells. So it's really, for us, it's helping to be a game changer out there, as you said, in the life of the valve, in the maintenance of the valve. But going back to the stainless steel, because one of the things out there is stainless steel will not be replaced when it comes to, I'm going to say, high salt or other chlorides. Um, it's an excellent valve. Obviously, when seawater or you're working with high, I'm going to say, chlorides out there. And, part of that is we fabricate when 4-inch and above, but we could actually make 316 stainless steel valves, and that's more of what we make when a high degree of corrosion is required. So depending on the application, stainless is still used, especially, in certain areas. Sometimes engineers just don't even want to have the headache of understanding, do I have if I have aggressive water out there, I'm going to use stainless. We again have tested, have worked on this, and are introducing it. We're hoping to change the field and to get out there to the engineers that now we have a really good cost-effective solution for the ductile iron compared to stainless steel.
So that would be, on the coasts, if you're BC, Seattle area, California, they may be looking more towards the stainless still.
They could be, but we're going to get into shipyards and stuff like that because of, where, again, it's based on application. But sometimes when the water's, let's say, a high degree of chemicals in it and a high degree of chlorides, so you may want to, have a stainless steel valve based on the processing, with maybe a Viton elastomer out there. So again, it's very application specific. It's some building owners, especially in a large high rises, use stainless steel valves because once they go in, they never want to have them replaced. Maybe rebuilt over time with preventative maintenance, but a stainless steel valve could last the lifetime of the building. So it's really pending on the application, the cost, and what an engineer is looking to do or spec in. So going to look at ArmorTech automatic control valve summary. One of the things is where an automatic control valve is used. And we have different, you could say, features on an automatic control valve. And one of the things we take a look at why we're armored, with ArmorTech and now automatic control valves is pressure management. And pressure transients, as I kind of said before, can cause extensive damage to water and wastewater transmission systems. With MIC, pressure transients can cause cracks, small breaks, especially in buried pipes, and end connections. A lot of these, you could say, little leakages are are acoustically undetectable because they're so small you can't even hear them. And these are seeps at the pipe wall and joints. One of the things is they can't really be repaired economically on an individual basis. You can't just start digging up in locations thinking I could find things. So really the level of pressure employed, affects the water leakage rates. So poor pressure management correlates to increased pipe failure rates. So when you start taking a look at this, why am I discussing this is with the addition of ArmorTech and really using automatic control valves, as we talked about before, we have an excellent long-term pressure management capability for the water infrastructure. Because really, again, we talked about before, MIC costs pinholes. So you really want to make sure all the valve parts are working very efficiently. And again, high pressure can be, supplied and then reduced, by many factors out there in the water system. So, from a fire hydrant being closed quickly to pumps being turned off, there are a lot of ways that high pressure transients are created. So with the addition of, we already had these control valves out there, but now putting ArmorTech out there, we open the scope up of a larger pressure management system that could be employed cost effectively. So, compared to putting in, I'm going to say, stainless and aggressive water applications, you could use a ductile iron valve for that pressure management system. Oops. Sorry, overshot. So one of the areas that is happening in, across you could say everywhere, is the use of recycled or reused water, um, which is considerably more corrosive to steel and copper than potable water, and generally contains higher amounts of dissolved organic matter. You know, um, these conditions are, favorable for MIC and lead to corrosion. One of the issues out there, because of water is becoming very expensive. So when we're starting to take a look at reclaimed water, it's being used in cooling systems, you could say, for data centers, chip building, uh, buildings themselves. So reclaimed water is finding its way into a lot of areas. And one of the issues is MIC, corrosion, and especially, the discharge from, you could say, treatment facilities where they're coming from. There is the recommendation, or you could say, part of AWWA is, treated water, could, from the reclaim could be between, let's say, 6 and 9 pH. Well, we sit kind of before, when that pH starts getting low, even below 6.5 or even a little higher than that, you start getting into aggressive water where it starts eating lead, copper, lead fittings. So the use of reclaimed water saves on the environment, but also creates problems in the valves. So this is where, again, a ductile iron automatic control valve, especially in for water systems under pressure, are effectively used. Corrosion from wastewater. Um, the majority, I'm going to say the average, sewage treatment system will be around, when it discharges, around 7.5 to 8.5. And the alkaline is very low. We talked that the alkalinities, to fight the acidity. And one of the issues is the hydrogen sulfide in the surrounding sewage system. You get acids forming, and we have turbulent conditions, which gets very aggressive on the valves themselves because of the velocity. One of the issues, especially in wastewater, is the bacteria, because they use a lot of oxides in the gas. So, you look out there, you get why sulfuric acid is formed and corrodes the sewer pipes. So, wastewater corrosion is really twofold. It's electrochemical. Remember, we talked about before, as you could say, the metals dissolve, they start changing the galvanic reaction. And then we also have hydrogen sulfide and MIC corrosion. So what Armortech does is, its coating helps prevent that MIC, that influence from the different gases in the sewage environment. And again, in sewage plants, coatings on metals are well understood in the wastewater applications. Oops. So the next is really, taking a look at corrosion, from industrial water. And industrial water, as you see, goes in many, many different aspects out there and markets. So, water is a critical component of all these industrial processes. One of the things, for, all these different organizations and companies is, the not only the industrial water, but the drinking water, the waste management, industrial water, such as I'm going to say like a tomato cannery where they make, packaged tomatoes, could have water as low as 4, on the pH scale. So there's a high acidity based on the um, food processing company. So the chemical qualities of water running through the ACV, is based on the alkalinity, the hardness, the pH. Everything influences the corrosive reaction. So when we take a look at the pH, anything lower, we, usually from about a 6.5 or could be higher than an 8.5, could create problems out there. Water flow rates with faster flow create problems. Water temperature, the dissolved gases, the conductivity of the water dissolves solids, which helps create mix. And certain bacteria, you got suspended solids, and you got different cleaning agents. So when you get to industrial water, there you could say it has many, I'm going to say, forms out there of corrosion that or helps accelerate the corrosion in the pipes, the valves, throughout the whole system. Especially when you get a lot of rain, CO2 sitting out there, and you get the runoffs into vaults. You get that, again, external corrosion on the valves. So what, again, ArmorTech does is it helps mitigate corrosion, and it, instead of using, again, stainless steel in some of these areas, it fills a nice cost-effective gap out there from scaling corrosion, MIC activities. And I threw a little thing there that, Cargill, big food processor, is moving towards using a lot more recycled water, in its from its water discharge. So kind of like, it's a high degree of sustainability. And what they're trying to do is reduce the fresh water or the potable water consumption in their processes. So they're using a lot of their own recycled water out there. ArmorTech ductile iron ACVs for shipyards. Again, why? Well, we talked about the salt spray, corrosion, but one of the things about automatic control valves, they provide drip tight shutoff. There's no packing glands, no breakaway friction, no external linkages, no lubrication is needed, and they have a very low operating friction. Why would the shipyard need a ArmorTech ductile iron ACV? One of the things, sitting out there is in these environment is they handle the distribution system, storage tanks, from not only potable water, but for fire. There's a lot of pumps startup and, and stoppage, and, it controls the surges in the pipeline. We talked about before that corrosion, the appearance of corrosion products are evaluated and, for a predetermined time. So when we talked about the salt spray, the test duration, generally, is 1,000 hours or to exceed it. So one of the things we tested the valves per ASTM B117, which is the salt spray testing, and we passed that ASTM condition. Corrosion from irrigation agricultural water. This is a very high area because there's a lot of dissolved solids and substances in the water from the fertilizers. So you got calcium, magnesium, sodium. You got many types of different chemicals and dissolved solids in the water. And these dissolved solids create the ions, or you could say the water becomes more conductive out there. And these dissolved solids bring really couldn't be used for drinking. Yeah, they're used for irrigation, but and the recycled water. But one of the issues, especially in irrigation, they try to use a lot of, I'm going to say, plastic valves. But when you get into higher pressure, higher flows, agriculture and irrigation, to put in all stainless gets very expensive, especially for a lot of farmers, a lot of people out there. So when used in irrigation and you have that high dissolved solids, you really want something cost effectively that can handle the water and for irrigation or for large agricultural fields. So one of the issues is the with these solids and this, you could say, very aggressive water, is that it builds also up in the soil. So when the valves are partly buried in the soil, they sit in vaults that naturally, from rainwater, the soil gets in there, or they may even just be buried partially in the soil. You also get a high degree of corrosion from that. So the ArmorTech helps mitigate that issue, and it becomes very cost effective to be used in the agricultural and irrigation market. One of the last things we talked about is at Watts we have an ArmorTech H-plate strainer for ACVs, and this is what this provides is a durable and cost-effective way to protect the piping and ACVs from damage caused by pipeline debris. It has a large flow area made of durable steels and can withstand harsh environments, especially like the ArmorTech ACVs. So it has that corrosion resistance. It has a very low pressure drop, and again, because it could sit, as you see in the picture, in the soil, which could be very aggressive. It has the ArmorTech coating for its life. So
before we dive into the summary here, had a question coming in from the chat.
Sure.
Looking more on I guess some of the specifics for some applications and whether or not the ArmorTech's available. So I guess generally, is it on all of the ACV lineup? And then specifically for like a fire protection surge protector, the LFM 11652, is it available on that model?
Yes, it's now available on all automatic ductile iron automatic control valves.
Yeah, so the general answer, I guess, answers both the specific and the general. So yeah, for your fire protection, for your pressure reducing, for flood protection, whatever you're using the ACV for, as long as it's in the ductile iron family, it will have the ArmorTech coating to it.
Yes, it will. Any other questions? Again, corrosion is a whole topic upon itself. So what we try to do is give a little bit of understanding of corrosion, not trying to go deep into it because it's very hard when you start talking pH, aggressive water, ions, you know, and that's what corrosion's all about. But what we're trying to give you is, explain how, why our product that nobody else has on ductile iron is improved with our advanced coating, our ArmorTech advanced coating, and we could really help out in that area. So really, when you look at this, is I hope, with the presentation that, it kind of gives you an understanding and helps explain a cost-effective solution to, ductile iron automatic control valves used in aggressive water. How we handle MIC, which is a key corrosion, or really the majority of corrosion out there. Give you some benefits of the ductile iron automatic control valves with ArmorTech, as just discussed. One of the things takeaway I hope you get is that we're not just spraying this on and saying, here it is. We've actually have had this out in the field in aggressive water applications and have field tested this extensively. And then too, as Zach said, we have this on our backflows and automatic control valves, and we are moving it into other applications like I showed you on the strainer, that is being ArmorTech coated. So we're moving this from a Watts perspective throughout many products that use an iron component in its construction. So, lastly, again, you got questions, you could email me or get a hold of Zach, out there. But we have, we can help you out and answer some of your questions out there.
Absolutely. And we'll stick around here for another couple of minutes in case any additional questions come in.
Sure.
I think one thing important to note, just as we're kind of wrapping up here, the Watts team, the ATS team, we're really focused on making sure that, the engineering firms have a really detailed understanding. You're showing the learning centers that's available here, where, I've attended with some engineering firms that went down to a week-long course on ACV, PRV, and backflow. Is fantastic. I got a great in-depth instruction on it. And I know there's various training centers across Canada and the US. So if you want your firm to, really get the in-depth version, we can help set that up. We do a lot of lunch and learns, both virtually and in person, where, if you're in Canada, we'll get Mo Fanous and the PRV backflow expert up here. Down in the US, we'll get the local rep and the product managers to be joining us for, whether it's in person or virtual, a lunch and learn on either this topic or any of the detailed Watts products available. I did one just a couple of weeks back, and it was more of an intro to drainage again. It's amazing the basics that you have to go over consistently. If you don't use them, you lose them. So sometimes you haven't done a project in a while, you need to get a refresher on, what is a backflow protection plan, or, how do you size your ACV? And we can certainly help out with all that. And whether or not you need the accredited course, or we can get a little bit more specific and into the nitty gritty, you can get your AIA or your ASPE credits. Or if you're up in Canada and you just need your CPD hours, we can help you out with that as well. And there's online training both with Watts as well as directly with ATS. If you go to atspec.com, you'll be able to hit the Learning Hub tab and review all of our previous ATS university sessions like this that we've recorded. You can also reach out directly to me, and there'll be a contact field there, and we'll help you get set up. Or you can go, I've done the Watts Works online training. It's fantastic. I'm pretty close to, I think, you get tokens and credits to get merchandise, and it's actually pretty decent stuff. That the camping chair looks pretty sweet, so I'm pretty close to that. I might have to watch a few more videos and learn it up. But hey, that was fantastic, Drew. We appreciate your time. We're already at the end of the hour here, so if anyone wants to stick around and ask any questions, we'll certainly help out and answer anything that comes in. But I learned a lot about corrosion resistance today, and I did not realize that the MIC was such a leading factor in the corrosion. And seeing that you can have a coated ductile iron product that's going to have reduced maintenance over the lifespan is certainly going to be a differentiating factor. So really appreciate your time and what we learned here today.
Thank you. Thank you, everybody, for attending and staying online.
There we go. So yeah, we'll hang out for another minute or two, but for any of them that needs to dip out, please feel free to get on to your next meeting, whatever it is. We'll be reaching out with your certificates of attendance. We'll also reach out and see if there's any additional information you may need, such as the Canadian map or anything like that. So yeah, you'll be hearing from our team soon. And like I said, we'll stick around and see if any questions come in. Yeah,
Thank you, Drew.
Thank yous in the chat. That was fantastic, Drew. Great job.
Thank you.
I don't see anything coming in, so with that, we'll let everyone dive out.
Zach,
thank you all again for joining.
I'll
we'll see you next week.
Hey, Zach.
Yeah.
I'll get you that the Canadian. See if I get that Canadian map for you.
Perfect.
I have that on my tick list. I will try.
Yeah.
Again, corrosion and aggressive water. People are paying more attention to now. Because of what's happening
especially
out there.
for the water reuse, like you were talking about. Like most large municipalities are looking at some sort of water reuse, either credit through LEED or just the green standard that city might and municipality might add. So, reclaimed water is aggressive water, fast water is aggressive water, hot water is aggressive water. There's all sorts of various aggressive waters out there that we have to handle, and it is having an effect on distribution piping and all the valves and components along the way. So
yes, it does.
It's a very current topic, and not a lot of people are going, not many developers are going to want to spend up to make every valve stainless steel.
Absolutely.
It's a very practical alternative that makes sure your products and your buildings actually last. It's I love practical improvements.
Now, is anybody else on the any more people on, or are we the only two?
Yeah, we still got a few people, but
okay.
I'm going to end the session here, and if you want to give me a quick call, we can have a debrief.
Yes. Which should I call you?
Yeah, just shoot me an email and I'll set something up for us.
Okay, Zach, you got it.
All right. Bye for now, all. Thanks for joining.